All right. I think that's the last person I knew of that was going to be showing up, so we'll go ahead and kind of get started. Thank you, everyone, for coming. My name is Brandon. If you don't know me, I'm with the Sewer Stormwater Division, and we're here today for an erosion sediment control plan inspection training. It's geared mostly towards the inspectors on the public works side, engineering, and on the building department side. But yeah, everyone here is obviously welcomed, and there will be some questions and answers at the end. Our presenter is with WGR, is Matt Lewis. He's been with them for the last 6 years. He is a qualified SWIP practitioner, and so he actually does these inspections and he does these trainings. I will let him correct the record on anything I misspoke, but if there's nothing else, I will let you get started.
Thank you for showing up and putting your faith in me and WGR. I appreciate it. So the first 20 slides or so will be a bit of legalese from a lot of the ordinance that comes from your city, and then the last 60 or so slides will be BMPs specific. So, you know, a lot of it will be pretty straightforward. A lot of it will probably be such that you're familiar with. So I shall get going. So what we will be covering in this section is ESCPs, erosion sediment control plans, the purpose thereof, the prohibitions, legal authorities, municipality ESCP plan BMP review, and when to inspect. So when you are going onto a construction site, you will be analyzing the site for whether or not they are following the ESCP plan. And it is focused on minimizing disturbed areas of soil and will control any runoff from a construction site. So the intent and purpose of this plan is to protect surrounding water bodies, enhance water quality of the city. And we are also inspecting sites in order to help protect and promote the health, safety, and general welfare of the citizens of the city by prescribing regulations to effectively prohibit non-stormwater discharges to the city's MS4s, MS4 municipal separate storm sewer system. And we are working to reduce the discharges of pollutants in the stormwater to the maximum extent practicable. When an inspector finds an issue, the municipality can step in and help protect the public by regulating non-stormwater discharges to the city storm drain, controlling the discharge to the city storm system from spills over land flow dumping or disposal of materials other than stormwater, reducing pollutants in stormwater discharges from the city storm drain system to the maximum extent practicable, and minimizing degradation of the water quality of water courses and the disruption or pollution of natural or city authorized drainage flows caused by the activities of clearing and grubbing, grading, filling, and the excavation of land, as well as sediment and pollutant runoff from other construction-related activities. Also, you are here to control industrial and commercial pollutant discharges to the city's MS4. Forgive the extensive verbiage. I just want to make sure I hit everything. Legal authority, very important. Okay, so the city has the authority to prohibit non-stormwater discharges, eliminate illicit discharges, and prohibit the dumping or disposal of materials or non-stormwater into the MS4. So as an inspector, finding an issue and reporting it to the municipality can lead to the city stepping in and, as I said, effectively prohibit non-stormwater discharges through the MS4s, detect and eliminate illicit discharges and illegal connections to the MS4, something that you might find, though not all that often, and respond to the discharge of spills and prohibit dumping or disposal of materials other than stormwater into the MS4. And feel free to stop me if you need. I'm getting through this, so it's quite a few slides. I don't want to keep you too long, but stop me if need be. All right, construction sites are legally required to implement BMPs, best management practices. As inspectors, you will be analyzing the BMPs of the ESCP, the Erosion Sediment Control Plan. The city requires operators of construction sites, new or redeveloped land, and industrial and commercial facilities to minimize the discharge of pollutants to the MS4 through the installation, implementation, or maintenance of BMPs consistent with the CASCA BMP practice handbooks or an equivalent. The CASCA is the California Stormwater Quality Association. An ESCP inspector ensures that the site is following the BMPs outlined in the respective plans. The legal authority of inspectors. Usually this is done by the Director of Public Works, but review and design proposals for BMP usage and maintenance, analyze stormwater operation and maintenance, the O&M plans, and you are able to enter private property to inspect sites for non-compliance, which is usually done at reasonable times, business hours kind of thing. Yep. The thing to remember as an inspector is that you are keeping you keep your eyes and ears open for non-stormwater discharges and other situations which could pose a threat to public safety and health. Enforcement powers and remedies. When there has been a site found in non-compliance, they can face enforcement, including abatement and civil action. Abatement is generally when the inspector has the authority to command the discharger to reduce, decrease, alleviate, mitigate, or stop altogether their activities. Of course, civil action is the city has the authority to levy a fine against the discharger for compensatory damages. Now, I usually do a quick aside here when it comes to your legal authority as inspectors. I tend to use a quick analogy that bears are attracted to sweetness as opposed to bear mace. So when I was first an inspector, I was, a hard you-know-what. I would take it rather personally when I would see soil or the water sources being polluted. And so I learned over time that being a hard ass about it doesn't get me very far, especially when you as inspectors, these are people that are working in your community trying to better your community. So the last thing you really want to do is create a bad reputation, because we already have it as inspectors. No one likes to see us on site. And so the last thing you really want to do is make that reputation worse than it already is. So I always suggest just food for thought, just be nice. Be nice about it. All right, abatement. Abatement can include the requirements to cease and desist of all activities that may cause or contribute to any discharge or condition in violation. You can command is always a sketchy word, but it's the truth, command the cleanup of any release of pollutants causing or resulting from the violation. You are also able to command the discharger to mitigate any circumstances that may cause or contribute to any discharge or condition in violation, and if necessary, submit and implement a stormwater pollution prevention plan, sometimes known as a SWIP, and or BMPs approved by the director for the correction and prevention of the discharge or conditions in violation. Furthering just a bit more, should a discharge on site occur, the procedure and remedies include an inspector can command, like I said, the abatement and cleanup of the site's unauthorized discharge, spill, or pollutant release within 72 hours of notification. High-risk spills should be cleaned up as soon as possible. So the 72 hours is pretty much a general thing with ESCPs or SWIPs. The state generally wants things at least addressed or beginning to be addressed within 72 hours. So it can take longer. Sometimes it does take longer. But at the very least, it should happen. Your dischargers should start to correct these things within 72 hours. And if not, you have the authority to ratchet it up. An inspector can require abatement within 30 days of notification for uncontrolled sources of pollutants that could pose an environmental threat. All construction activities can be required to cease until such problems are adequately addressed. If a situation persists where pollutant-causing sources or activities are not abated and any responsible parties contributing to the spill can be billed if deemed necessary. Now, usually the 30-day thing is what most cities give their contractors. They want them to start within 72 hours, but usually it's typical that you won't come back for another 30 days or so because you're probably swamped with other work. So that's pretty standard to give them, hey, I'll be back in 30 days. I might be back in 3. So, please get on it kind of thing. And then you can require a new time frame and notify the Central Valley Regional Water Board when all parties agree that the cleanup activities cannot be completed within the original time frame, and notify the Central Valley Regional Water Board, we're all here in Region 5, in writing within 5 days of the determination that the time frame requires revision. So sometimes that's the case. I've had sites that the erosion is so massive and the damage is so extensive that 30 days is probably not going to cut it. I have one site that took months and months and months. And it was a site that was going to be, or could have been regularly inspected by a state inspector. So if you think that's the case, just notify the water board. They are very reasonable people. All right, moving on a little further. Civil actions are legal remedies taken by the city against a contractor. The city may levy citations or administrative fines, require recovery and remediating costs, impose more substantial civil or criminal sanctions, comply with construction runoff control code, and comply with post-construction stormwater management. Sometimes I give an example where a site is letting sediment go into the MS4. It's clear that it is just bombarding the storm drain with sediment. And sometimes cities will bring in plumbers to snake the MS4 to see with video footage if that's the case. And so that's something that is sometimes really beneficial for a city, because you don't want your systems packed with sediment, and you definitely don't want to let off a lazy contractor if they're doing that knowingly. So that's just, again, some food for thought. Sometimes if you think that you're getting bombarded with that sort of thing, you might want to have an investment into see if you can get a plumber or whatnot to check out your lines, and then that's something that the contractor would be responsible for in that fee of the city's fee of getting those guys out there. And of course, you can require inspections and enforcement. All right, we're getting there. We're getting through the tough stuff. Civil actions, calculating the cost. As I said, compensatory damages for diminished water quality affecting the public or wildlife. So that's pretty serious. And the city has all the authority to go absolutely crazy, because that is, that's a terrible thing if you're polluting the water or the public or the wildlife. Reimbursement to the city. And payments can be up to $5,000 a day. It can actually get way higher than that if you start digging into the construction general permit and what can happen if they are knowingly polluting. They can actually be thrown in jail. And so, sometimes these little hints to contractors that are giving you grief will go a long way. Yes, as I said, criminal violations. A violation shall constitute a misdemeanor. Any such violation may, at the discretion of the city attorney, be charged and prosecuted as an infraction. All right, so a little bit more here of the technical stuff. All projects that disturb soil could be subject to the construction site stormwater runoff control requirements. Projects which are subject to these requirements include but are not limited to, but this is mainly what an ESCP plan will fall under, is projects that disturb 1 acre or more and are part of a larger common plan of development, or projects which disturb less than 1 acre, which is usually an ESCP plan. That tends to be what these fall under, is less than 1 acre, which is why your sites won't be required to have a SWIP, because a SWIP is 1 acre or more of soil disturbance. So, a lot of it is patios, pools, walkways, kind of pretty minimal stuff. But it can jump into a SWIP if it's part of a larger common plan of development. So something to keep in mind. And this is probably more for the director, but we'll go over it quickly anyways. Prior to issuing any building or grading permits, the city will require an ESCP plan to be reviewed and approved. Any ESCP plan must contain the appropriate site-specific BMPs meeting minimum requirements for stormwater pollution control due to construction activities. Any additional BMPs which may be required will be at the discretion of the city. In cases where a SWIP is developed, the city will accept this as a substitute for an ESCP plan. However, any additional BMPs may be required by the city prior to approval of a permit. An ESCP plan is basically a dumbed down version of a SWIP, but it more or less has the same requirements when it comes to BMPs. All right, what should an ESCP include? The city shall include, or the city shall require, the inclusion of rationales for using their BMPs with any supporting soil loss calculations. ESCPs should also include erosion and sediment controls, soil stabilization, dewatering if needed, source control and pollution, measures per the CASCA cut sheet, and ESCPs should list, ESCPs should list all applicable permits associated with their grading activity, such as a 401 water quality certification, a 404, which is the U.S. Army Corps of Engineers, which has to deal usually with fill and dredge. And you might run into it up here, the California Department of Fish and Wildlife 1600 stream bed alteration agreements. Note, evidence that additional permits are obtained will be submitted to the City of Chico prior to soil disturbance activities. So they're usually in addition with the plan, with the SWIP. But that's something to keep in mind, is sometimes they will, contractors will provide you with the plan and not get the permit, these additional permits. And so that's just always something to be aware of, but the director will probably be on that. All right, when can inspections occur? Now, we generally say at any time. Usually it's between business hours. I mean, no one wants to go on the weekends or outside of business hours, but what type of inspections exist? Routine inspections ensuring BMP compliance when it comes to grading, filling, clearing, grubbing, or excavating activities. Random inspections, which involve sampling stormwater discharge. Inspections sampling areas with evidence of stormwater contamination, illicit discharges, or discharge of non-stormwater to the storm drain system, as well as where there is a reasonable cause to believe that there exists in any building or upon any property a condition constituting a violation on site. So it's really just at your discretion. ESCP plans, really the only mandatory requirements for inspections are prior to disturbing soil and after post-construction. But we, as consultants, always suggest that you do it at least once a month, especially during the rainy season, or like it says here, if it's a suspicion of contamination, or if you have a site that is known for contamination. I mentioned earlier to Brandon that we have a site, I'm from Lodi, it's a winery. They contaminate every single year. They just let their sludge go into the storm drain. They literally do not care. They've been tagged by third-party litigators, by the city, I think maybe even the state, and they just look at it as an operation, cost. So that's just something to keep in mind. You can, I think I have further in the slide, you can actually shut sites down for a period of time, if it comes to that. But, if you're proactive, you hopefully will not run into this problem, but some contractors are just, they're a bit hard-headed, and it just doesn't matter. So this is just generally what a paper form would look like. I wouldn't be surprised if y'all have a digital form. For instance, we use a digital thing that we have. We actually rent it out to all different types of companies. There's other ones. It's very minimal fees, but it's basically the digital version of this. And it's really handy for keeping records because usually you need to keep these things for a period of 3 years. So, and if you are dealing with the 2022 construction general permit, for instance, if you have a SWIP that falls under the new permit, pictures are now required. And so that's where having a digital, access to a digital format comes in handy because, it's hard to attach pictures to a paper form. But if you have things that are still under the 2009 permit, I'm getting a little outside of the ESCP plan, but if you have 2009 SWIPs, no pictures are required with that. So it's just a little food for thought there. So this is the typical ESCP compliance list. All right, so now we are getting into a little bit more of the BMPs. I guess I should mention this prior to submittal. ESCPs must be reviewed by a QSD or someone who is qualified and knowledgeable in the technical review of erosion and sediment control measures or is supervised by a QSD. So PEs and CEs can technically self-certify that they're QSDs, but that might not guarantee that they have the expertise or the knowledge to properly review these things. So often there is a time gap between the plan submittal, the plan itself, which it can change. You can submit a plan and then suddenly find that it can change, and what occurs on a construction site. So inspectors are really there to make sure for the city that the plan is being implemented correctly on site. This is a typical ESCP plan. They're usually pretty rudimentary. They'll have a key, a direction, site direction. They'll give you, like this one here has silt fence, erosion control mats, and DI locations in the general perimeter of the site. So they're usually pretty minimal, but excuse me, when you want to go on site, you generally want to have the map in hand, or at least if not, then to be very familiar with what you're supposed to be seeing on site, because it's just a really easy way to make sure that everyone is in compliance. All right, MS4 basics, how often you should inspect. So generally, this frequency is based on a certain criteria. It's not set in stone, but this is generally how we see it. So it's usually, a site will have a high, medium, or low risk. And obviously the higher the risk, probably the more frequent the inspection should be, versus, or say you have a site on a hillside versus a flat site. You should probably inspect the hillside site a little more frequently. It's pretty straightforward. But usually what you take into consideration is the sloping of the site, the size and type of project, the sensitivity of the surrounding bodies of water, the proximity of the site to receiving water bodies, the number of non-stormwater discharge potentials, and if the projects have a past record of non-compliance on a construction site. And as I said, at minimum, inspections are to be required prior to land disturbance, especially during the rainy season. and during active construction and following active construction or post-construction. Yeah?
I didn't want to stop you earlier, but this morning we touched on today's meeting. Can you explain the difference between the QSP and the QSC?
Yeah, QSD is a qualified SWIP developer. He's the person that makes the plan. And a QSP, which for all intents and purposes, y'all will be at this point, is someone, a QS qualified SWIP practitioner, and they are the people that make sure that the plan that the developer created is implemented appropriately. So when I showed you that, the site map, that's a QSP, right? So the QSD will have made that plan, and the QSP will then make sure that that plan is being implemented on site. Now, a QSD can do this as well because a QSD is technically a QSP, even though some QSDs don't go out and get the additional certification, but a QSD is more than capable of doing the inspection. But that's generally the basics. The developer develops a plan, the practitioner makes sure that it's being put into practice.
And that it's working?
And that it's working, yes, of course. Yep, to make sure that it's installed correctly. For instance, when we go over BMPs, we'll touch on how to properly install a fiber roll. For instance, a lot of contractors, just throw the fiber roll on the ground versus keying it in and staking it properly. So that's kind of, the QSP is basically the stickler. Just goes around and, make sure that everything is being practiced appropriately. Yeah. All right, BMPs, the exciting part. BMPs are our best management practices which prevent or decrease erosion, sedimentation, and the contamination on site. Wow, pretty fancy. Okay, erosion is generally defined as the detachment of eroded material, and they're usually covers. That's how you can kind of think of it. Erosion control is usually covering the soil. Then we've got sediment or linear controls. Sediment controls try to slow or control the discharge of eroded material, the movement of eroded material. And then, so those are basically the main two, erosion sediment controls. I threw in linear controls because it's kind of the same. And then good housekeeping. So with ESCP plans, these are probably the three things that you're going to just focus on: erosion control, sediment controls, and good housekeeping. And probably more than anything, good housekeeping, which is basically good site management, keeps the site clean and orderly. Erosion control. What is erosion? As I said, soil erosion is a process by which soil particles become detached by water, wind, or gravity and are transported from the original location. There are there's basically, I'll just minimize it and say there's basically one type of erosion, and it's splash. Generally comes from a raindrop. And then you have sheet erosion, which rainwater collects the eroded material and moves it along the surface, removing particles of soil also in the process. All right, so we'll start seeing pictures of eroded material. So here we have what is known as rill erosion, which if you can see, wish we had a little bigger, but you can see the lines coming down the slope. Basically little channels. Areas of high concentration of rainwater develop small channels which cut into the top of the soil, known as rill erosion. Gully erosion is when that just gets further out of hand. If rill erosion is not addressed, rainwater will amass and cut further into the slope, causing large gullies to form. And then you have gully erosion. If rill erosion, let's see, did I do that all right? Yes, If rill erosion is not addressed, rainwater will amass and cut further into the slope. And then you have, it looks like I skipped one on accident, but you have channel erosion, which is basically if a gully gets way out of control, it creates basically a river. So again, this is all pretty straightforward. But this is, this is probably the main thing that most sites deal with apart from basic erosion during the rainy season, especially during summer, is wind erosion. Wind erosion is wind that carries dirt, which is detached from the ground, and saltation, suspension, and creeping. So suspension, pretty straightforward. You get a big dust cloud, comes off the site, and stays suspended for a long period of time. Saltation is for instance, I know it on a baseball field. You get a big gust of wind and you get sand or dirt that'll sort of be sprayed. It'll go airborne for a second, but it comes back onto the ground. And then you have creeping, which is much heavier particles that don't go airborne but will be moved. So that's the three types of wind erosion. So now you're, totally, you can talk about wind erosion with all your friends and seem super smart. Or they'll just be really annoyed with you. All right, so we're going to talk about BMPs when it comes to erosion. So believe it or not, the number one best BMP when it comes to erosion is scheduling. So obviously, if your site is about to start and it's at the beginning of the rainy season, you're probably going to have a lot of erosion. It might be advantageous for the contractor to wait. Sometimes this can't always be the case, but it can be cost effective to simply just put the project off for a few months. It's just something to keep in mind. And we always say that it is the cheapest. Sometimes it's the cheapest BMP. You have, yes. Reduce erosion potential through restricting work in the rainy season. The most cost-effective BMP. Okay, this is a new one for the 2022 permit. I'll just briefly, usually you have 5 BMPs. In the 09, it would be non-stormwater controls, run-on and run-off controls, erosion, sediment, and good housekeeping. So in the new permit, you have this new one, which is preserve existing topsoil. Not a lot of people would think about this, but when it comes to post-construction, you're going to want to see natural vegetation. Usually, if you're dealing with a SWIP, it will be at least 70% of full vegetated growth. So say you have a lawn, you want to see that lawn at its 70% growth to consider it final stabilized. But a lot of times is what happens on a site is they'll strip the topsoil off and they'll just discard the topsoil. And I don't know if any of you know, but this can take hundreds, if not thousands of years for this topsoil to develop its microbiome. And so this is why it's a new requirement in the 2022 permit to preserve existing topsoil. It can be a pain because you have to find a place to store it. You've got to cover it and protect it. But it can save you in the end because a lot of times you'll have hydro seeders come in at the end, spray it, but a lot of the times you don't want to spend that extra money to have seed put into the hydro mix, which can be a significant amount of money, and it can be kind of a pain in the butt because you usually want to get the native vegetation mixed into the seed, which isn't always mixed into the mix, which isn't always available. So that's why the state has made this one of the fundamental BMPs, which is preserving existing topsoil, which, it really does help if you can bring that native soil back to your site. All right, moving on. As I said, with soil binders, mulch and tackifiers are temporary BMPs lasting 3 to 12 months generally, depending on how significant your rainy season is. I've seen them last a little bit longer. I've seen them last, not long at all. And especially if, for instance, be sure that they are applied according to the manufacturer's spec and instructions, and be sure to provide ample cure time to prevent chemicals from being transported by stormwater runoff. So that's a thing that I see a lot with contractors is they don't want to bring the hydro seeder out until the very last minute because, they can get it all done at once. It's more cost effective than getting them to come out during every section of completion. But usually this happens right before the rainy season. And so the hydro seeders, the hydro mulchers are usually swamped So a lot of times you can't even get them out onto your site, or you get them out literally like a day before the rain comes. And usually it can take at least 3 days, at least 72 hours for these sprays to set up. But usually we want to give them probably at least a week, you know, because that's just really frustrating and incredibly, you know, it's just a huge expense to just watch all your hydro mulch and everything just get washed, especially if it's getting washed into your MS4. That's a serious bummer. Moving on. Straw, mulch, geotextile mats, and wood mulching are great erosion control BMPs. Personally, my favorite. I think the geotextiles or the mats are the best, especially on hillsides. I have a later slide here that shows where they actually put down what we just will call it an erosion control blanket, right? And then they hydroseed on top of that. And that is, you know, it's biodegradable, so you never have to pull up the matting. You know, the grass vegetation can just grow up in between it. And it's by far the best thing, especially when you're dealing with hillsides. Moving on. Soil surface erosion controls are not always enough to prevent erosion, especially on a slope. If velocity dissipation BMPs are not used along with soil surface protection. So this is definitely the case where we can see on hillsides specifically or slopes, hydroseeder will come in. I see this a lot of times on levees. You get hydroseeded and then you won't put any linear breaks, because pretty much the biggest battle that you deal when it comes to sheet erosion is velocity. So when water starts to speed up, you're going to get much higher rates of erosion. And so you can see in the slide we've got check dams on the right, compost stock check dams on the upper left, and looks like just gravel berms used as check dams there in the center. And so that's just something to take into consideration, that not only do you want erosion cover, but you want velocity dissipation. And with those two things, you're going to be well on your way to preventing erosion, for sure. And here was just an example that I was just mentioning right here. So it's kind of tough to tell, but it is a black matting that they put down there, and they're hydro spraying on top of it. So this is, and it is on a slope, so I can only assume that linear controls will have gone down as well. So it's really the trifecta, you know, the erosion control cover, the spray for the natural vegetation, which, you know, the roots, right, they bind everything in place, and then you would have the velocity dissipation. All right, so this is, this next slide is, as well, this is a fantastic BMP. It's often known as soil surface preparation, also known as roughening or track walking. Whereas you can see, got the bulldozer going up and down the slope, tracking, creating the footprint of the tracks in the slope, which are actually little tiny velocity dissipation devices. And so so a lot of times on levees, for instance, this is a levee here, contractors will save an expense by track walking. And, you know, it works. And one of the interesting things is it also encourages natural vegetation to occur much more rigorously, because in the dips of the tracks is, like, say, that's where rainwater will collect, and it's just like a little pool right there, and it'll encourage that natural vegetation to happen arguably quicker and in a much more vigorous manner. So, but when it comes to track walking, a lot of contractors don't like doing this because it costs a ton when it comes to fuel, right? Because you have to imagine when you're going just up and down, up and down. Most track walkers just want to go all the way across, creating perfect rills with their tracks, which will actually speed up erosion. So something to keep in mind. Contractors don't like to do it, but I always suggest, well, if you don't do that, then you're going to have to add linear controls. You're going to have to buy, Lord only knows how much fiber roll, to string across a levee at, multiple increments. So track walking is a great erosion control. And now is almost always used on levees. Most contractors have caught on to that. So just some basic definitions of linear sediment controls. Devices that are meant to slow the velocity of eroded material / sheet flow. Then we have drain inlet BMPs, which can be fiber rolls, compost socks, rock bags, drain and inlet guards, which protect DIs from controlled and or illicit discharge. Then you have perimeter controls, which are, as they say, they stop the soil from exiting the site and or entering the drainage system. Okay. So here are some good examples of linear controls. And this is probably as a QSP, when it comes to linear controls, you're basically going to just want to go on site and make sure that the contractor has put in enough linear controls that the QSD has called out. So a lot of the times they're going to want to skimp in this area. Say the developer wants them every 10 feet, and there's a little spec here, so the developer will know based on the slope, the height of the slope and the steepness of the slope, how many to put in place. It generally falls in between 10 and 20 feet, give or take. But obviously with the steeper slope, you're gonna have more linear breaks, and that's something that you'll just wanna keep in mind. It's always a good thing to check, in the ESCP plan, or if you happen to be dealing with the SWIP, I should be seeing linear breaks every 10 feet. A lot of times I'll go on site and it'll be every 20 feet. And, so that's just something to keep in mind. This is where your kindness as a QSP, when you have to talk to your contractors and tell them they have to double their expense when it comes to linear controls, it really goes a long way. Because they hate putting linear controls. Okay, into some drain inlet protection. I threw some extra pictures like this little orange silt fence thing. You usually don't see that too often. Generally what you're gonna see is rock bags, which are almost never used correctly. And I personally hate them. My favorite is the green compost sock, because the thing with compost sock is, number one, it's weighted, so even if you're using it on linear breaks or a perimeter, they don't have to be staked in like fiber rolls do. And fiber rolls, for instance, they don't allow penetration of water. We use an example of, if you go into other countries, that you'll see like straw thatch rooftops. There's a reason why they're using that straw, is because it doesn't prevent, it prevents water from getting through. The good thing about compost sock, and also with the fiber roll, it doesn't, if water does happen to get through, which it usually doesn't, but if it does, it very rarely cleans the water. It doesn't usually remove particles of sediment. Whereas compost socks, they're self-weighting, and they remove particles, and they allow water to flow through them. So we always suggest, though most contractors, again, don't want to do it because it's a bigger expense, but compost socks are by far like the greatest option. You can see the black rock bag there. If you put a compost sock there, you will never have to do what most contractors do during a rainstorm, is that rock bags are very similar to fiber rolls. They don't want to allow penetration of water, and it pools up, right? And so a lot of times you'll see rock bags put around DIs, and it's like, okay, they're installed perfectly, but when you come after a storm, or if you're doing a during storm inspection, they will have kicked the rock bags away from the DIs because you're creating a puddle there, and they're like, hey man, you're creating a puddle on site. Come on, we got to get rid of this water. And especially with the SWIP, when you get that WDID number, you have a permit to discharge, right? So a lot of guys will say, well, I got a permit to discharge. I need to get this off site. Oh, but now you're just discharging, you know, muddy water into the DI. So you can't have, usually what will happen, a sort of middle ground, is they'll use rock bags, but then they'll drop in these drain inlet sediment traps, which they're pretty good. A lot of them don't get the sediment traps. They'll just get, it's like a black, they're black, it's an equivalent. It usually just catches leaves and stuff, but it doesn't really drain or filter the water. So that's just some food for thought. But compost socks, they're a little more expensive. But what's also great about them is when you're done with them, or if they get damaged, you can just slice them down the middle, you know, and dump them into the yard or, you know, into the field or whatever, because it's just filled with compost. We actually have demonstrations at our shop where we plant stuff in them. You know, we can plant strawberries and onions and plant all kinds of stuff in them just for fun, lettuces. So they're very environmental friendly. Probably over the next decade or so, they'll pretty much take over everything. And then we just have some BMP perimeter controls, which, as they say, they guard the perimeter. We have this standard here on the left, which is staked in more or less every 4 to 6 feet. This is something that an engineer or director will call out. And then up at the top here, or here, the next slide, we have compost socks as an alternative, which are nice because they're self-weighting. You see one here that's staked, and I believe the only reason they were staking that is because they were having such a significant amount of sediment runoff. As you could see, that compost sock used to be in a straight line, but so much sediment was hitting that compost sock that it moved it into this U shape. So they staked it, which is, you know, not a bad thing, but the nice thing about compost socks is they usually don't have to be staked. So that's a little cost saver there. And they're amazing products. And then we have on our next slide, silt fences, which, so silt fences, definitely if you're, you know, doing work near water, it's by far what you're probably going to want to use. And you can see in the background why they have this big rock buffer is because they're working on a hillside. So you can see that hillside in the back there with its terrible erosion controls. The tarp just, you know, sloughed off to the side. So the gravel will slow the flow of that sheet flow coming down, and it will help get those particles to settle out into the rock. And of course, you've got your silt fence. The key thing with silt fence, like with fiber roll, is you want to make sure it's keyed in. You know, a little trench is dug out, it's partially buried, usually about 6 inches or so, then covered up. And also the thing with silt fence is it's a little difficult to see here, but they actually, with the silt fence, you'll want the stake on the opposite side of where the flow is coming, right? Because if you have it on the side that the flow is coming, it can just, because it's just stapled in, right? So it'll just get pulled off. But usually what you want to see is the stake on the opposite side of the flow, and then what they're supposed to do is staple it in first and then twist the stake around so it sort of wraps around as an additional, you know, it reduces the potential of that ripping free, and then they stake it in. So usually what they never do is the added twist. So that's up to you as inspectors if you want to, you know, call them out for that. Technically, that's what it's supposed to do. I almost never see them do that, almost never. But like if you can actually see on the opposite side, you can see if you can actually see the stakes, it's obvious proof that they haven't twisted the silt fence around it before they staked it. So just FYI. Now this is interesting, curb cutbacks. Okay, so curb cutbacks are a 6-inch curb cutback is a state-approved BMP. It is a perimeter control. This is a cost saver like you would not believe. If you have curbs, you know, and even if you're trying to remove your curbs eventually, leave them in for as long as possible, because what's better to have a pre-existing curb that's already there or spending money to put fiber roll down? So a 6-inch curb cutback is a fantastic BMP, and it replaces the standard fiber roll. So that's something, usually the only thing with that is that you just want to make sure that your contractor is keeping a 6-inch curb cut back. A lot of times they get impacted with sediment, they fill up, and they never want to shovel it out. But whenever they start griping about that, it's like, hey man, you're not spending money on fiber roll. So, get on it with the shovel. Get a few guys with the shovel and we'll save you a ton of money. So, curb cutbacks, great option in replace of fiber roll. All right, so now we'll get into when BMP controls fail. So on the right, this is actually a site of mine that I have been trying to tell them for over a year that their fiber roll is a mess, it's all squished, but they've got that curb cut back there. And so I'm like, hey, you guys, okay, just come in here and clean up this curb and you won't have to put the fiber roll down. Now, of course, they never listen to me and they just come in and put fiber roll down. I don't know if they're like writing it off or what they're doing, but here's a perfect example of a totally flattened out fiber roll where they could just deepen that curb cut back and save themselves some money. But if they're not going to do that, a lot of times the certain parts of this specific site, the surface soil is right to the curb. So they would, they'd have to probably bring in a little tiny excavator and it'd be significant, maybe, I guess. I don't know. It doesn't seem like it would cost any more than redoing this every year. But that's just something, food for thought. But this is a lot of times what you'll see. In lieu of a curb cut back, it'll be a smashed fiber roll. Or on the left, you will have, this always happens, the guy in the little yellow shirt, he was part of the landscaping crew. So this is a site that is getting pretty close to being done, and the landscapers hate fiber roll. It's the bane of their existence. And so they will come in and remove the fiber roll. Usually it's piled up in the street, covered in sediment, right next to a storm drain. So usually what I was trying to tell these guys, okay, if you want to get rid of the fiber roll, put in a curb cutback because you have your sidewalk there. Of course, they didn't want to do it. And they're just tracking tons of sediment out into the sidewalk, which of course I ended up having to take a sample that day because it had just rained and the gutter was full of sediment and water, and they got charged a nice sample fee when they could have just kept that perimeter control in place. So this is clearly a terrible perimeter control here that is not being implemented properly. Excuse me. Okay, and now we have silt fence. So these are all my sites. This is the site on the left is always in a state of disarray when it comes to this silt fence perimeter. It's massive. It's probably a couple miles long. And of course they don't, we're actually going and having a meeting with them about BMPs, and they're trying to find other options for this silt fence because it's a huge expense, a serious time consumer. But it's kind of hard to tell, but there's a natural stream bed down there, which the state water board has already been out. It's a protected water stream. And sometimes, or not sometimes, but a lot of times, this silt fence wasn't keyed in. And as you can see, it's a little hard to tell, but the big dark spots are actually erosion that started forming and working its way under the silt fence. So if they're not keyed in, now this is not always gonna work. You can sometimes install this stuff correctly, and water is a serious force to be reckoned with. But this silt fence was not keyed in properly. And it's led to massive amounts of erosion and huge time and cost loss. And here is another site that I have where, again, it's not, it's starting to fail, again, right over a stream. It's like, of course, it always fails right over the stream bed. And it's a little difficult to tell, but right by the orange stakes, they're not keyed in. And so at another portion of this site, there's a little bit of erosion that's coming down, just slipping under the silt fence. So this is like the kind of thing you're going to nickel and dime your contractors about all the time. Silt fences not being keyed in, fiber rolls not being keyed in. Those are probably the two things that you're going to see the most is not proper installation or proper maintenance. Let's see. All right. Okay, so this is clearly a disaster. This is the silt fence site. Major development, tons of action going on. To their credit, they try, but they are always, it seems like they're always 2 steps behind. But they have a curb cut back here. But what was just there was a stockpile. And they also use it as a little entrance and exit, which is not, there's no track out controls. But obviously, that is a recipe for disaster with all that sediment in the gutter like that. And so further on in my slides, I'll have some stockpiles. But one thing you always want to do with stockpiles is try to get your contractors to set it back at least 6 feet from the curb. Because usually what happens, which is kind of a pain in the butt for them, because usually what happens is they just back up to the curb and dump the stockpile, right? And they will argue, oh, well, if I have to go up onto the curb, I might damage the curb. And so that's something to take into account. But it's usually never that bad because it's not like they're constantly dumping stockpiles like every single day enough to actually damage the curb. And a lot of the times they will dump it either just next to it or partially on the curb. And so, again, this is just a perimeter control that has failed. They've eliminated the stockpile, but the remnant is still there. And this is sort of a silly one that we like to put in. But is a chain link perimeter control, approved? Obviously not. But what is interesting is that any type of perimeter control, even a chain link fence, you can see actually is catching a significant amount. That's a good 6 to 8 inches of sediment that had come down off that hillside and was caught. And so even a janky old chain link fence can, do some work, to catch that sediment. And this is also, I don't know if I have, I don't think I do, but this is a little side. So when it comes to run-on controls, a lot of people, runoff is pretty self-explanatory. Your site sediment water is running off your site. But run-on controls is something that people sort of struggle, I know I did for a while, to understand what exactly run-on controls consist of. Usually you would think of another site running onto your site. But actually the most typical run-on controls is your site onto itself. Think of a new development where they've graded out the streets. Usually the pads are a little bit higher and they grade out the street. Well, what usually happens during a rainstorm is that the rain will erode the material on the pad and it will run into the graded street area, right? So it'll create erosion on the pad and it will bring sediment down into where the street is going to be, where all the lifts will be taking place. Which not only have you degraded your pad, the slope of the pad, but now you've added sediment into a pre-graded area, which now you're going to have to get graders to come back out and regrade. So you can have, so at the top of this hill is actually run on. Now, technically, this would be from another site, if I'm not mistaken. This is, but I try to remember exactly because I see equipment in the back. So it could be run on from your site to your site. But essentially, you would want at the top of that hill, usually it's a fiber roll or a silt fence, but it tends to be a fiber roll because you're going to want to prevent whatever sheet flow is coming to the top of that slope. And then as it's eroding down, that's where you're getting the velocity, which is creating essentially what will be soon enough rills, right? You can sort of see those channels starting to develop. And so you would probably want to have even a linear control there to prevent the velocity from speeding up. And their solution to it all was throw a fiber roll down at the bottom, which, okay, they're trying. But they probably could have prevented all that erosion by simply sticking a fiber roll at the top of the slope and maybe even one across the middle of the slope. And they probably thought this is fully vegetated, which here you go, fully vegetated slope. You would think you're not going to have any issues. But it turns out even on this little tiny slope can't be more than 8 feet tall, maybe 12 feet long or so, that even a fully vegetated slope is going to get erosion. So that's just, again, why you need not only erosion control, but velocity dissipation. All right, so linear controls when they fail. So this is a site that I have. It's a landfill. It has more erosion than I've ever seen in my life. It's in the middle of Livermore. It's in the hills, significant. You'll see in the next slide some of the erosion that happened last year during those 12 atmospheric rivers or whatever. But, so even you can see they've done their best. They've done their linear breaks. I know it doesn't look like a slope, but it is a slight slope. It's going into their drainage area, and it's just overwhelmed. So that's something that that contractors tend not to want to do is general maintenance. You know, get back out there. And of course, who wants to go out there and slop around in that mess to reestablish their silt fence? But you got to do it. And here you can see this is actually the slope of that basin last year. It's kind of hard to tell, but that is definitely a channel. It's not a gully, it's transferred into a channel. And the problem here is that they didn't anticipate properly the flow. So they have their linear controls. They actually have erosion controls. You can see the natural vegetation has already started to grow, because this is actually in the winter time, believe it or not, it was just a sunny day. So their natural vegetation was growing. They had hydro seed, all of that. They had their linear controls, but you can even see the tiny little rills running down from the linear breaks. But the problem with this is that they didn't anticipate that the flow was going to come down parallel to the linear controls. And they just had massive amounts of erosion. So sometimes when you face, 12 atmospheric rivers, there's only so much you can do. BMPs can only get you so far. And it's just the way it is. But this year, they actually totally stepped it up and they rocked that entire channel. And this is a massive hillside that they rocked the entire channel. And they also put rock check dams, and they went insane. They probably doubled their linear breaks, and they haven't had any problems this year. Of course, we haven't experienced the amount of rain as we did last year, but they haven't had any problems. So, and last year, all they really had was just rock check dams, hydro seed, and on the sides they had the linear breaks. And all the water just went underneath all the check dams. And it was literally 40 feet deep at some spots, maybe even deeper than that, and probably 30 to 40 feet wide. I've never seen erosion like this before. Rather impressive. Okay, and so here, you actually, again, I threw this one in because they did seemingly everything right. You can see they had silt fence up at the top. They've got silt fence down below. They've got linear breaks. They did have natural vegetation, and if I'm not mistaken, the plastic sheeting that you see there is when erosion started to happen. A lot of times the quick and easy fix many think is throw plastic on the eroded channel, right? But what that actually does, and what that did here, is because they didn't put any velocity dissipation through the channels, which is really hard to, how do you get fiber roll to stay on plastic? Usually what they do is just rock bag it. But when you put plastic down, that actually is a velocity increaser, right? It speeds up the velocity of the erosion, which ended up here. It's kind of hard to imagine how this happened, but it just turned into an absolute debacle. And you can actually see that they did key in. It's kind of hard to tell in that second channel there, but they did key in their silt fence. They actually had fiber roll on the top of the slope. And I think personally, my opinion on this is that the slope is too steep for the distance. They only had one coming right down the middle. with this, and you would have to get into the math, but I believe that it should have been probably
Every 4 feet.
give or take when it came to that linear break. And if I'm not mistaken, those linear breaks were not keyed in. You can kind of tell it further down that they're just staked in. They're not keyed in, right? A little trench wasn't built and they weren't set into place properly. But I show this because sometimes you can do seemingly everything right and Mother Nature will just get the best of you. And so this would be a case of, as an inspector, right, you have a totally disastrous hillside and yet your contractor seemingly did everything that you asked for, put the plan into place, maybe even went overkill, and still you have a disaster. So this is where you wouldn't want to be such a tough guy and break them off really badly. You'd want to give them some time to try to, obviously they need to fix this because this is a disaster, but so it just goes to show you that you can do everything right and still have BMPs fail. And if there's any, this is also a really scary thing. I kind of was talking to Brandon about it a little bit. When it comes to being a QSD or someone who designs these things, you can do everything right and you can still have catastrophic failure. And luckily, no one is threatened here, but what if this was on the side of a building development, and all this was going into someone's backyard or into their living room or into their pools or whatever. And so this is just something to bear in mind, that your best laid plans, you can go by all the stats and everything, and it can still turn into a disaster. So again, just something to think about. All right, so BMPs, DIs when they fail. So as you see in the middle, this is generally what I see. These are all my sites. This is what I see all over the place still to this day. They've got the DI rock bags kicked out from the curb, right? Because they are like, hey man, it's creating a puddle. And so normally what I would suggest to them is to remove the middle part, because what the bag is, you can see it in the bottom one, the bag is actually doing what it's supposed to do there, even though a recommendation of my part would be remove that, right? Get rid of that built up sediment. But the DI bags, that's what it's supposed to do. It's supposed to create a little channel, kind of like gold panning, right? You're trying to get the water to hit it, to go around, but to slow that flow so much that those heavy particles drop out, right? And so this rock bag is actually doing its thing, and but a lot of times it'll just keep building up and building up and building up, and then it stops being effective. So it's something in your report you'd be like, yeah, properly installed, but you'd probably have a note, remove excess sediment buildup. And then you have the fiber roll on an impervious surface on the concrete. So obviously you can't stake it in, you can't key it in, and the water is literally just going to flow right underneath it. And so my guy is like, oh, well, what do you mean? I got my DI control. And then, like, hey man, come on, come on. Like, yeah, okay, you're right. And so they actually put compost sock around it. That's what's on it now, is compost sock. So, track out controls. All right, so as you can see here, you got some pretty nice track out controls. Usually the top right is what you have, and obviously their purpose is used to prevent sediment from leaving the site via construction vehicles. Now, when it comes to, of course, I always tell my guys, city inspectors, the number one thing a city inspector will cause a city inspector or a state inspector, regional inspector, to stop at a site is track out. Because they can pretty much assume that if this BMP is a mess, which is the one BMP more or less that is the most visible to the public, and if they're allowing this to be a mess, there's probably plenty of things on site that are also a mess. Because if they don't care about the number one visual, they probably don't care about what is not being seen by the public. So it's a little odd for me to say, you got to watch out for city inspectors is what I tell my guys. But you guys, as I would tell you, that if you see track out, you got to stop. Because more than likely there's concrete washout that's a mess. The DI is a mess. Their housekeeping really their housekeeping is going to be an absolute mess because track out generally falls under housekeeping. So that's just something to keep in mind because a lot of times city inspectors don't have enough time to inspect all sites, especially during a storm season, you know, or say if it's just a rainy day and you want to go out and try to hit all your sites, you know, if you actually have to stop, you can be an hour or two on site, and what if you have 5 or 6 sites to hit? You know, you're going to probably have to pick and choose. Going back to the frequency, you're going to have to try to figure out which site is, you know, most a threat and which should I be looking at first. So if track out's a mess, it's a guarantee that the site is a mess. Here's a perfect example. So on the lower left, they've got track out. Now this is also something that I'll see is they'll actually have track out controls. They've got their big chunky rock. But what happens is that this is actually a site that they're just using as a stockpile holding site. So the trucks will come out and will slowly either crush that rock, pulverize it, or usually what happens is they fill the track out up with sediment and the track out becomes basically invisible. So it's something that you have to call them out. Usually they call it re-scarifying the track out, you know, get an excavator in and churn up that rock and get that track out maintained. And the middle is, or let's see, yeah, the middle here, or a middle right is they just literally don't have track out controls. And this was actually the site a few ones back that I was talking about, the landscapers removing the perimeter control. This is all the landscapers right here. This is just on the other side of the street. They've got a little mini excavator and they're tearing up some sidewalk and they're just tracking out like crazy. And of course, once I showed up and started taking pictures, you know, they lose it and they're like, what are you doing? I'm like, I'm taking pictures of your track out. I work for the contractor that hired you. You're now gonna potentially have to pay for this sample that I'm about to take that is way outside of, you know, the numeric action levels. I'm like, I'm sorry. Like, well, sorry, dude, it's too late, you know? And of course, what they usually want to do is they want to take a hose to it, right? They just want to spray that all down. So it's a real, because I don't know what you do at that point, right? How do you clean that up? This was the day before as a pre-storm inspection. So, you know, how do they clean that up? It's caked onto the street at that point. So they've really dug themselves into a, you know, into a pit. And this is also something that you will see where have a nice perimeter control that, of course, isn't keyed in properly, but they'll just make up a new exit or a new entrance, right? And yeah, so they'll just run over the silt fence and start tracking it out into the street. All right, we're getting there. We're so close, we're getting there. Okay, good housekeeping. Stockpiles, concrete washouts, vehicle maintenance and fueling, material storage, spill prevention, and response. Whoops, let me go back. Sorry. So this is generally the housekeeping that you'll need to deal with. Stockpiles. Stockpiles generally need to be, if they're inactive, which this is sort of a new thing, there's generally a rule of 14 days of inactivity of exposed soil is when you need to stabilize it or cover it, but the state just sort of adjusted that in a sense to where if it's an inactive stockpile, it needs to be covered and burned at the end of each workday. Now, you know, we can argue about what inactivity means, and contractors will definitely argue with you about that. And so that's just something to keep in mind, that stockpiles need to be contained, moved away from the curb, that sort of thing. And they generally, I'm trying to remember now exactly, I think it's 12 feet is the maximum height of stockpiles. I would have to confirm that, but it's, you know, generally no taller than your average person, which a lot of times they're a lot higher than that, but something to keep in mind. And then obviously concrete washouts is going to be a huge problem. A lot of sites don't want to deal with it. It can usually be nothing more than a kiddie pool, on site, and they would prefer to just dump it into the yard where landscaping is going to go over and hope that you won't see it. And for instance, the bottom right, that was a site of mine, a winery, where they were laying a bunch of pads. And the guy, as I'm walking up, I'm seeing him, he's washing out his chute right onto the exposed soil, which now has grapes planted in that exact location. So I walk up to him, hey man, this was when I was a little bit more of a jerk. So I actually got into it with this guy. This was a few years ago, maybe like 4 or 5 years, and I started yelling at him, what are you doing? He's like, oh, my bad, because he had his bucket right there, right? So I'm like, dude, you're supposed to wash out, they connect the bucket to the chute, they wash it out, and then they're supposed to take the bucket and dump it back into the mixer. So I get him to start doing that, and then I noticed that he didn't dump it back into the mixer, he just hung it back up, and then he turned around, drove out, and got out into the main road, and jumped out and took the bucket and threw it into the neighbor's vineyard, right? And so concrete guys and me, we've got a long history. And this was actually maybe the day that I just had to laugh about it, and it was a change in my personality, where it's like, obviously me being a jerk didn't have any effect on this guy. It probably did it maybe in spite of me. And so now I go about dealing with concrete guys in a much more reasonable fashion. And I don't really see this that often anymore. But it's something that'll happen, concrete guys. And then so you have, in that upper middle, you're gonna wanna see, it's kind of hard to see what that is, some sort of, I don't know, maybe it's paint. I can't remember exactly what it is, but what we really would wanna see is secondary containment for those, put it into a storage container is usually what we like to see. And then you have the porta potty, and if I'm not mistaken, this picture was the cause of the actual porta potty company itself, right? They come and maintain the porta potty, so they sucked out all the stuff, but then they always, spray it down. And what they're supposed to have is, which they don't here, and why I added it, is a secondary container on a porta potty. And they would, when they would wash it out, it would go into the tray, and then they have a little device that they could suck it out. And so that's why I added it, because that's probably, again, when it comes to housekeeping, one of the number one things you'll see is not secondary containment of the porta potties, which you definitely want. All right, it looks like we're getting to a little bit of stockpile management here. So, as I had talked about before, you can see fiber rolls will be, it's kind of hard to tell with this graphic. It's not the greatest, I apologize. But a fiber roll should be keyed in, a little trench, 3 to 4 inches, keyed in, laid in, and staked down. But when it comes to compost socks, or we have gravel bags, they're self-weighting and you don't need to do it. But the idea with the stockpile, having it bermed, is because usually the standard thing is putting plastic over the top. But when you put plastic over the top, you create accelerated velocity. And so usually it's on dirt, the stockpile. And so if accelerated velocity comes down, you create a nice little trench of erosion around your stockpile, which I guess you could then lay your fiber roll down in that nice keyed out trench. But this is something that you're wanting to prevent, is that accelerated velocity. And that's why you'll see a lot of stockpiles will have rope sandbags. And of course, it's not exactly, because it's not usually around the whole perimeter, but they're trying. Not only are they trying to keep it in place, but they have the idea that this will potentially slow the flow of the water. Hydraulic mulch, which you can always use, a geotextile, and those are usually never used. Usually it's plastic sheeting, which is not the best because, especially in the summer, it can degrade. And so this is just a few examples of stockpiles. So the center one, I guess, would be considered the best. I mean, they're trying, they sort of have it bermed. The stockpile isn't exactly covered. You can kind of see on the backside it's come uncovered. And then to the right is just, they throw a bunch of pallets on top of it and fiber roll. They're trying to do something. That lower right one is my landscapers again. This was what was causing some of that track out into the street, is they had dumped a huge pile of dirt there. And then in the center, you have, this is actually not too bad because this was an active stockpile, but they were still burning it. So, that would, to me, be pretty good. And then to the left, well, the center one you have obviously looks like topsoil to me. So that's an example of what I talked about previously with preserve existing topsoil. And then that lower one is usually the type of stockpile that you will get, gravel stockpiles, you'll get a lot of wind erosion. And so those are the ones that you'll tend to want to get covered, especially during the summer. They're just going to be whipping up all kinds of wind erosion. All right, we're getting there. Okay, concrete washouts, again, which are usually just an absolute disaster. The big bends are the best because they have a company comes in, drops them off, they fill them up with concrete washout, and they usually harden to a degree, and then the company comes and picks them up and removes them. Because this is why contractors don't like to deal with stockpiles, like for instance, the kiddie pool is, okay, usually what happens is they'll buy a kiddie pool, and then they'll buy another kiddie pool, and then before you know it, you got a dozen kiddie pools filled with rock hard concrete, and no one wants to get rid of them, right? Number one, it's a big pain in the butt. You got to get excavator or something to pick them up because they weigh a ton. But a lot of times you see a sort of combination. This is all the same site. Those three bigger ones. The one in the middle is a little, I just had to throw that in there. It's the stockpile that they had tied up to their now I'm drawing a blank on their scaffolding. So I don't know why they thought that was a good idea, but that was their stockpile. I guess technically it wasn't leaking, so I don't know. I didn't give them a pass, but they tried. But usually what happens is some sort of lame attempt of screwing together 2x4s with sheeted plastic, and they create a Mickey Mouse version of a concrete washout, which, as you can see, generally never works because it usually turns into what's down there in the middle center, where it usually fills up, spills out, and just gets everywhere. So the top left is the best option, but it's the rarest to be used, but it's always the best. So that's just something that this is something that I always break contractors off on. I'm never lenient when it comes to concrete washout, never, because this is a contamination of soil. And I always say the one thing that we can all get on board with is to prevent the contamination of soil and the contamination of our water sources, right? Everybody can get on board with that. So this is something that I always ding them with. I never give them any mercy when it comes to concrete washout. And I always tell my inspectors to do the same. Because if they can actually get on top of their concrete washout, they'll probably be on top of everything else. So, but that's up, at your discretion.
What are they supposed to do with the kiddie pool later?
With the kiddie pool, like when it's all filled up, it is difficult because, like, for instance, I took this photo just a few weeks ago, and it was right before a storm. And it wasn't fully hardened over, right? So the storm's gonna come in and just overflow that kiddie pool. And you're right, it's really difficult. What they usually do is they get an excavator or forklift of some sort, and they pick it up and put it into the dumpster. And that's really their only option, and that's why I always suggest to just bite the bullet and pay for the big, half dumpster, because then you can tell, like if you're on a big development, you can say, look, guys, here's where the washout is, right? Everyone put your washout right here, right? You don't have to put a kiddie pool at every single lot or whatever, which is usually what they do. And then you have someone take care of it for you. So it's that is expensive. It's like $1,500 to $2,500 to get one of those stinking things in there. And it might even be more these days. But it's definitely what you want to suggest. It's definitely the better option. It's less headache for the contractors in the end. And they always like it once they have it. They never want to pay for it, but they always like it once they have it. All right, a little bit of vehicle maintenance, and this will be usually like on your plan, you will have a storage area that's usually graveled. Usually the developer, the QSD, will call for like a graveled area where usually concrete washouts would be, where porta potties would be, where materials would be stored, vehicles would be stored, and it doesn't usually happen, as you can see. Like this is just a recent site that I have on the down left, where you've got the big soil excavator, right, parked in the middle of a lake. So, you know, those things are always leaking hydraulic fluid and everything else. And so I had to get those guys to move it to the higher side of the site, which was literally just a fully graveled portion of the site that, if I'm not mistaken, the SWIP called out as their storage area, you know. But yeah, so in the top middle, it's just a pump that pumps water out of it, but it still leaks, and they usually have it on a plastic sheeting. And then the yellow, if I'm not mistaken, is a generator, a big massive generator, which you know, is leaking. I think that's fuel, if I'm not mistaken, onto the ground. And I threw in this chain link one just because a lot of times, well, I don't know, a lot of times, many times I will go onto a site and it's closed up, especially if it's raining, right? And so this is the best you can get, right? In barring that you're actually climbing the fence, which, you know, I wouldn't suggest. But I threw that in there because a lot of times this is the best that you can get when it comes to inspecting a vehicle. And so do what you can, you know, snap a picture of it. In the report, say that the site was locked up. I couldn't access the site. For my best visual inspection, it seemed like nothing was happening. But you know, you would probably need to go and check that if you could. But I figured I'd just throw that one in there. All right, we're almost there. Material storage. So as you can see, most of these are done fairly well. A lot of times, like concrete will come, or landscape material will come all plasticed up. That's really nice. And so most of these are pretty good. The one on the right with the concrete, with the terrible plastic covering, I don't know why they're doing this, but they do it. I see this all the time because, especially during the rainy seasons, like you just got that photo, if I'm not mistaken, not too long ago. And, you know, you get water on those concrete bags and they just harden right up. So I don't know why they're just throwing money down the drain, but it's something you need to call out, because when it comes to materials like wood, you don't really need to worry about wood being exposed. Even a lot of metals, you know, I think the water board is going to start getting on that, like rebarb, for instance, it'll rust. And, you know, so that's something that it's only a matter of time that they'll want to see in secondary containment. But, and it usually is nothing more than a storage bin. All right, and spill prevention. So this is something that you as inspectors will probably want to ask for. So especially if you're stopping based on track out, or you're stopping based because you see like fuel spill, and it's required, excuse me, every site is required to have a spill kit and a spill response team, which is usually the superintendent. And it generally is no more than a bucket, a shovel, some cat litter, maybe some absorbent materials. And you're gonna wanna see, usually what a state inspector will always say, where's your spill kit and where is your spill personnel? Where's your spill team? And so that's why I usually train the superintendent, because they're probably always gonna be on site versus just a general laborer. And so you just want to have a spill, make sure that they got a spill kit, that the guys on site, now technically they do like tailgate meetings, usually like once a month, maybe once a week with the crews. And so you'll want to reiterate that all your guys need to know where the spill kit is. But generally, it's just 1 or 2 guys are technically in charge of the spill kit itself, usually the superintendent. But that's something to ask for as inspectors is, do you guys got a spill kit? And they'll be like, well, what? Which they usually never do. I mean, even I tell them to have it, my sites, they hardly ever do, until something happens. So it's just something to get on them about. Okay, and when it comes to sampling, just so you know, I figured I'd throw this in here. NAL's numeric action levels generally for pH is between 6.5 and 8.5. And the turbidity is below 250. The turbidity is how much sediment do you have in your water. And essentially the basic thing here is report it, see something, say something, let the discharger know that he has 3 treatment options, which you will see here is a treatment train, passive treatment, or active treatment. Now these are all pretty extreme treatments. Usually what happens when you have an NAL exceedance is a fiber roll has blown out and sediment is leaving your site. Something a little more typical than that. You have excavated material just flowing off site. But if it gets really crazy, like you'll see here, this was, if I'm not mistaken, in San Jose. They're doing a significant building project in the middle of winter. So they're constantly pumping out of that pit incredibly sedimentated water. And so this is a treatment train. This is something that usually you don't plan for as a QSD, but it's something that if you happen as an inspector to sample and you have NAL exceedances below 6.5, above 8.5, and or above 250 NTUs, this is a pretty good option. Doesn't take a lot of effort. This is basically 3 sections of mulch and some sand. And so what they would do every day is, you can see they got the little spigot here, and they are pumping into it. And if I'm not mistaken, they were way outside of their limits. And as you can see through this nice little rill coming down, they got within their NAL. So they got it down to 8.30 for their pH and under 250 at 1.8 NTUs. And so believe it or not, just flowing through, if I'm not mistaken, they were in like the 400s for NTUs, and their pH was like through the roof and like in the 9s. And so just surprisingly, they go through 3 sections of mulch, and they're also going through some compost socks, 3 sections of compost sock, and it brought it down. And this works almost every single time, and it's a pretty cost-effective thing, a load of mulch and 10 or so compost socks and some sand, and you've got yourself some clean water. And this is getting a little more technical passive treatment. These are flock logs. They're basically polymers that attract the negative particles of sediment. A lot of dirt is negatively charged. And the water flows by these logs. Here's a much better version of a flock treatment. And it causes the particles to bind together. They become heavier, and then they fall out. They become too heavy to just wash out, and they fall to the bottom of the stream. And this I put in here because this is really a pretty good example of, they have erosion controls. They've got their flock logs, which are actually doubling as velocity dissipation devices because it's actually slowing the flow. So this is a really great treatment for excessive sediment and going into a stream bed. And this is my last BMP slide. We'll do a couple slides for mock inspection, but this is active treatment. This is significant expense. Sometimes it's absolutely needed. It's fully automated. The NTUs for this are 20, so they're very low. They have to follow the pH range, but their water has to be almost perfectly clean. And sometimes I have, like at the site out in Livermore, the waste management or whatever, they have active treatment systems. as you might imagine, they don't necessarily need some active treatment. They've got a lot of biological stuff, all kinds of different stuff. So these ATS systems, active treatment systems, are really quite effective. They are an extreme expense, but I wouldn't be surprised, it's only a matter of time before you guys come across sites that acid treatment isn't working, and it's got to be something insane like this. But more than likely, the contractors will have already known that they will need this stuff, and they're just waiting for you to call them out. But as you can see, that's quite the setup. All right, so last few slides. This is where you get your participation. So this is an inspection that I just did about a week ago. And so I usually just ask, what do you see here? What, if you were an inspector and you saw a DI looking like that, or you saw it, I think I had forgot to mention, so I'll give you a little cheat. When it comes to trash bins, they're supposed to be covered at the end of every workday. So that's my little helping cheat there for you, is that those trash bins aren't covered. And they can actually be considered discharge points, usually with the trash container. That usually you're going to want to tip them up just slightly at the front, right? Because imagine if that thing's getting filled with trash and all kinds of stuff, and it gets filled up with water, or whatever water hits it and just starts flowing out all that beautiful trashy water. You know, that's technically a discharge point that you would need to sample. But you know, what do you think about that DI? If you had to say, what would be the number one thing you would put in your report about those DI bags? Yep, excess sediment, is that what you said? Yep, exactly. That's exactly what I put in the report is, you know, to remove built up debris, excess sediment, something to that effect. And then again, with the dumpster, this was a pre-storm that I was doing, so I was going to say, you know, you guys need to cover your trash cans. That's what I put in the report. Of course, I don't do it. You know, but. No, yeah, it's because, and no one likes it because if you put a tarp during the rain season, what's going to happen? You're going to create this big puddle, right? So I totally get it, but you know, we as inspectors, we always say we're just calling balls and strikes. Just calling balls and strikes, and whatever the erosion sediment control plan says, the SWIP calls for, if it says, according to the state regulations, that these things need to be covered at the end of the day, I put it in the report. I always tell my guys, look, man, I'm a dog without teeth. I'm just barking at you, but I'm never going to bite. But you guys actually can bite, so I'm a little envious of that. You know, you can wave around your ticket book and, you know, go crazy. But so, okay. Next one. And now I realize with the left one that I probably should give you another cheat. I'm pretty sure I mentioned it, but when it comes to exposed soil, generally it's after 14 days of inactivity, we want to require some sort of erosion control, because this was during the summer, really windy area, just tons of wind erosion. So this is a thing that you will always fight with your contractors over, and they will probably never do it. This site, for instance, is hundreds of acres, and of new developed subdivisions. And of course, you know, what do? You tell your contractor he needs to hydroseed hundreds of acres of exposed soil, right? Of course, they're not going to want to do it, and they're going to complain to me, and then I will say, well, you should have never graded that, you know, a year ago, right? You should have just left it fully vegetated, because then you wouldn't have me on your back. Like, oh, well, then I would have had to have them come out again. Like, well, then you're just going to have me complaining for the next year or so about this, you know, and you're going to be sending all this soil into the atmosphere, or whatever, right? And so I'll give you that little cheat on the right there. What would you say potentially there? Yep, no perimeter control. It's kind of hard to tell, but that little box there is technically their trash can. So that's, you know, clearly not a sufficient trash container. And then they have their material, their construction material, which it looks like a lot of wood, but they had like bags of spent concrete, They had nails all over the place, you know, which are going to rust in a rainstorm. And it just looks like a general disaster. So, you know, and you can kind of see that sediment is starting to peek out over their curb cut back. This is one of my sites that always prefers to have a curb cut back, but they don't always stay on top of it. Okay, so this one, no help from me on this part. Track out, is that what I heard? Sweeping? No perimeter controls. Yep. Stockpile right next to the curb. Exposed soil that's definitely been exposed for longer than 14 days. The stockpile, they might be able to get around saying it's active. But yeah, they've just got a ton. And also you can see the further trash bins there in the background are not covered. Okay. Kind of more of the same. This is all the same site if you had to guess. Yeah, the fence is, yeah, it's maybe a little high, but that's only because it's not keyed in. Yeah, and so you can see to the left, there's sediment running across the sidewalk there. And if we had this a little blown up, you would be able to see that they didn't key it in, and wind, that's just wind erosion, is blowing those silt fences and just kicking that soil, that sediment across the sidewalk. And yep, and the bags aren't, you know, at least they're trying. They got them installed fairly well. Although the whole L thing, I'm not a huge fan of the L because it kind of prevents that water from flowing around it, which you want to be able to get your water off site, and that tends to pool. But they're trying. But yeah, their curb cut back's a little bit of a mess. They've got tons of sediment in the curb and gutter, and their track out is all over the place. They got exposed soil that's longer than 14 days of inactivity. And if I'm not mistaken, it's a bit hard to tell, but there's even some concrete washout there next to the curb. Believe it or not, this is the last slide. So what do you see on that porta potty? There's one thing missing. No secondary container, that's it. And as I had mentioned with Brandon earlier, technically porta potties need to be fastened down. They should be roped with sandbagged or staked into the ground, because a dumped over porta potty is, yeah, something that no one ever wants to deal with. And that's actually a non-visible pollutant sample, which is a sample that has to go to the lab, and it's quite expensive. So porta potties should always be fastened down if you can help it. And then that middle slide is what does it look like? I know these are a little. Yep, just debris, not contained in a trash can, and yep, just out in the middle of an exposed field. And then this one on the right, if you can tell what that gray stuff is, washout on the soil. And they tried to be tricky about this one. They went behind the houses and dumped the washout behind the houses, thinking that I wouldn't figure out how to get back there, but I did. So that's it. Thank you so much.